Okay, so in this lesson, we're going to be talking about absolute value transformations. So this first part, it's talking about composite transformations. So it says a blank occurs when two or more transformations, meaning it's going left, it's going up. So two or more transformations are performed on a graph of a function to produce a new function. This is called a composite transformation. To determine which transformations have been applied to an absolute value function, consider the following questions. So whenever you're checking for a reflection, you're looking to see, is there a negative value multiplied on the outside? Is there a variable on the inside that's multiplied by a negative? So those are your reflections, remember the negative. To check for a vertical or horizontal stretch or shrink, compression, is there a factor multiplied on the outside or on the inside? So that's what you're checking for there. Checking for vertical and horizontal translations. So you're looking to see, have you added or subtracted on the outside or added or subtracted on the inside? So those are the ways that you'll be able to figure out your reflections, stretch, compressions, and translations. So what we're going to do on example 1 is we're going to look at the graph of function g, which is plotted on the graph, and you're going to figure out what the composite transformation would be based on your parent function, so the absolute value of x. So if you don't remember what that looks like, you can graph it. If it helps you seeing your transformation. So that's not necessary, but if it helps you, you can see what's happening. So first we're going to figure out the verbal description. So notice that first thing I notice is it's opening down, which would be a reflection over the x-axis. And then also notice that your 0, 0 point has been shifted left 2 and up 1, 2, 3, 4, 5. Okay, you also need to check for a stretch or a compression. So normally our points are like 1, 1, 2, 2, 3, 3, 4, 4. So let's check that. So from that point there, notice it's going right 1 but going down 1. So that's that reflection there. So there wasn't a stretch or a compression. So we're going to write this in function notation description. So we're using f, which is our parent function. So the negative, the reflection over the x-axis is a negative in front. I'm going to write f. And then if we're going left 2, remember that's the opposite that you're adding to your x. So in parentheses, you'll have x plus 2. And then your up 5 is changing your y on the outside, which would be plus 5. So there's your function notation description. Then we're going to come up with the actual equation. So I'm going to call it g. And so we have negative on the outside. We have absolute value bars. We're adding 2 on the inside because it's going to the left. And then you're adding 5 on the outside because it's going up. So there's your equation for that particular graph. So if it helps you to draw out your parent function, you're welcome to do that. Okay, so looking at number 2. So you can compare it to your parent function right here. So normally it's at 0, 0. Notice there's no reflection there because of the, it's not opening down. So your vertex point, which is your point of your V, has been shifted right. So I'm looking at this point. It went right 1 and down 1, 2, 3, 4. Also check for a compression or a stretch. So notice you're going right 1, up 2, right 2, up 4. Normally it's 1, 1, 2, 2. So you're having to multiply those y values by 2. So that would be a vertical stretch. I'm running out of room. By 2. So you're going to have to check your points there. Okay, so writing your function notation, we're using f. So first thing, the stretch by 2 goes on the vertical, goes on the outside. And then on the inside, we're going right 1, which means the opposite. So we're going to be subtracting 1 on the inside with the x. And then we're going down 4, which means you're subtracting 4. So there's our function notation description. And then we'll actually write our equation. So I have g of x. There's a 2 in the front. I have the absolute value bars, and then x minus 1, and then minus 4. So you're having to look at your graph, find your transformations, come up with your equation based on your new graph. Okay, so let's take a look at 3. I'm going to have to do some erasing here. Always comparing to your parent function. So notice it's opening down, so we know there's going to be a reflection. And then notice that my 0, 0 point has gone up 1. And then we need to check for a stretch or a compression. You can clearly see there's something happening. So what I would suggest is find an actual point on a whole number, which is here. So that would be, you're going right 3, down 1. So normally it would be 3, 3. So the negative part is the reflection. So 3, 3, but notice it's 3, 1, which would mean you are multiplying by a third. So we have a vertical compression, because it's a fraction there, by a third. Okay, so my function notation, I have the negative in front for the reflection. My vertical compression is in front, so negative 1/3. F, we're not shifting left or right, so nothing needs to be inside the parentheses with your x. And we're going up 1, so we need to add 1. Okay, so my new equation, g, would be negative 1/3 in front, absolute value of x, we're not changing left or right, and then the plus 1. Okay, so you're having to check that graph, find your transformations, and then change it to function notation, and then write it in your equation form. Okay, on the back, we're going to be writing the transformed equations, so the opposite. So we're going to be given the description, and we'll have to come up with that g equation. So number 1, the function is reflected over the x-axis, vertically compressed by 0.3, and then shifted left 4. So when we write g, make sure you put an equation, so there has to be an equal sign. Reflection over the x is a negative on the outside. Vertically compressed by a factor of 0.3 is on the outside. And then we have the bars, because we're starting with absolute value of x. And then we shifted left 4. Remember, with left on the inside, you're adjusting your x. It's the opposite. You add 4. And then notice there's not a vertical stretch. So that is our answer there. So number 2, the function is stretched. So go ahead and write g of x equals horizontally by a factor of 2. And then translated 10 units down. Okay, so remember that stretching horizontally is the opposite. So that will go on the inside, and we'll multiply it by x. So 1/2 times x. And then there is no horizontal shift, so we'll close it, going down 10, so minus 10. So remember, if it's horizontally, it's changing the x on the inside, so it's always the opposite. So that would be 1/2 there. Okay, number 3, the function is reflected about the x-axis. So that's negative. Vertically stretched by a factor of a, so we'll just put an a on the outside. And then translated c units to the right. So inside the bars, we should have x minus c. And then there's not a vertical shift, So that's all we have to do there. So sometimes it'll just throw a letter in there and you'll have to just put the letter instead of a number. Okay, so the next three, we're given function notation. We're referring back to our f, and we're going to write our function g. So the negative on the outside we put. On the inside of the bars, we do exactly what it shows us, x minus 3, and then the plus 6. So not too hard there. So given your function notation in terms of f, we're just changing it to our g function. Okay, so next one. We have the 3 on the outside. Inside the bars, we have a negative x. And then on the outside, we have the minus 8. Okay. All right. 6. This one's a little different, but everything that's on the inside is what we put inside the bars. So put 5, put parentheses, x plus 1. And then close your bars, and then the minus 7. So whatever is on the inside there, that's what you put on the inside of your vertical bars for an absolute value. On these last three, we're going to be describing and graphing transformations from equations. So we're going to be given the equation, we're going to come up with a verbal description, and that will help us with graphing. So I want you to do that before you graph because it'll be easier for you. So first, write down what your transformations would be looking at your equation. So notice the 2/3 in front, that's vertical, and it would be a compression by 2/3. And then we have a, looking on the inside, it's adding 4, so you're going left 4, and then the minus 3, you're going down 3. So what I would suggest is start with your 0, 0 that you normally have on your parent function and go ahead and shift that point, so it'll be easier. So go ahead and go left 4, 4, down 3, 1, 2, 3. So that's your point of your V. Now you're going to look at your 2/3 in front. So that's actually the slope. So you can actually use that as the slope. So if you remember from linear, when we graphed those a couple weeks ago, you do rise over run. So we could go up to right 3. My bad. And then do the same thing up to right 3. Now that's just one side, so you know it's the same on the other side, so you would go up to left 3. And so there would be your absolute value graph. Okay, so now we're going to write it in function notation description. So we'll have the 2/3 in front, and then remember in place of the absolute value of x, you're putting f of x. So I have f, open parentheses, x plus 4, close your parentheses, and then the minus 3. So that will be your function notation description. And now let's take a look at number 2. So we have a negative in front, so we know that's going to be a reflection over the x-axis since it's on the outside. And then we have the 1/3 on the inside. So remember when you're writing your verbal description, the inside is the opposite. So that would be inside's horizontal. And that would be a stretch by 3. Okay, so notice that we did not shift left or right, so our 0, 0 point will stay there. Now what I can do to find my other points is I can use that 1/3, and I can use that as the slope. So I'm going to go, instead of going up 1, right 3, though, there's a reflection over the x-axis. So I would need to go down 1, right 3, down 1, right 3, and then do the opposite on the other side of the V, down 1, left 3, down 1, left 3. And there's our graph. So the function notation for that, if we look up at the top, there's a negative on the outside, and then we'll do f of 1/3 x on the inside. So that's our function notation description there. Okay, so let's look at this last one. Lots of things on this one. So notice there's a negative in the front, so that's going to be a reflect over the x-axis. There's a 2, so that is a vertical stretch by 2. And then notice inside the bars there's a negative, that would be a reflection over the y-axis. And then inside parentheses we are doing x minus 1, so we would do the opposite, remember inside, so that's going to be going to the right 1. And then the plus 6 on the outside, we go up 6. Okay, so I would first start with the 0, 0. We need to shift it right 1, up 6. And then we have a reflection over the x and y axis. Now, this one here, the slope is -2, so it would go down to right 1. Down to right 1, and then the opposite would be down to left 1. And remember that the y-axis one on the V doesn't really matter because you're just doing the same thing down the middle, so it really doesn't matter there. So that would be our graph. And then the function notation description, we would have the -2 on the outside. We would have f parentheses. We're putting everything that's inside the bar. So negative x minus 1, close your parentheses, close it, and then add 6. That would be our function notation. So if you have any questions over this, please let me know.